Hello everybody, I'm Dr. Leonardo, and today I will give you a brief overview of the research that is being carried out here at MCAST related to the field of space debris impacts, but also with applications in aviation. So I'm here a senior lecturer in aviation and also for the master in aerospace engineering, and I'm also a pianist pioneering space art, and I will talk more about this very soon. So now, very brief overview. The orbit, above all, the orbit around our planet is becoming more and more polluted with so-called space junk that probably you heard of in the news. Space debris, mainly of human nature, are a considerable risk growing more and more for all the missions that are operative in orbit. Just to give you an idea about the huge kinetic energy connected with an impact that happens in orbit, here you see a 2mm sphere that, just 1 gram, sorry, that has a kinetic energy comparable with an impact of a medium-sized car or of a hand grenade. So we're talking about also with a very small debris, about a huge energy that impacts structures in space with different effects. And here you can see some famous examples, for example, related to the International Space Station. Now, in the framework of Malta this year upgraded its status within ESA, European Space Agency, for the plan for European cooperating states, and there are different projects that are being developed also here at MCAST. Now, SPARTACUS project is a study partially financed by Xjenza Malta with the IPAS program, that is an explorative study that bases its structure on two big projects. The first one is the project that ended last August, where both for aviation and aerospace, we developed a methodology, a new methodology, to design 3D printed shields in Kevlar and carbon fiber. And here you can see some examples on the left for spacecraft and on the right for aviation. And linked with these projects, we have also the students that now are doing their dissertation project. So it's also a learning opportunity for these students. Now, here you see an innovative type of simulations done in collaboration with SkyUp Academy in Italy, where we managed to shorten considerably, getting still reasonably good results, the simulation time. These simulations are very time-consuming, and also in terms of power process. And here you see an example of real tests that were carried out. So you see an impact. This was at 5 kilometers per second of a 3 millimeters aluminum sphere. And this shield was 3D printed Kevlar and carbon fiber. And here on the right you can see some snapshots from the high-speed cameras. So this was the first project on which SPARTACUS is building up. The second one, which I'm truly proud of, is the ASTROBEAT project. It is the first fully branded by MCAST space mission that currently is on board the International Space Station. And here we are tackling the issue of space debris, not developing better shields, like for this project, but testing an innovative technique to repair damaged spacecraft already in orbit with using at our own advantage a phenomenon that is called cold-welding adhesion. So, from science fiction, we are passing to science. And just for a brief overview, cold-welding is basically when two metals are able to weld with, let's say, ambient temperature, provided that there are enough forces. Here on Earth, due to the atmosphere and gravity, these forces are relatively high. In space, this changes a lot. And the first time that this was discovered was with a Gemini 4 mission, where the American astronaut did the first EVA, the first spacewalk, extravehicular activity for US, that after this beautiful spacewalk, coming back, was not able to close the hatch of a spacecraft, of a Gemini. And after a while, they managed to close and to come back safely to Earth. But that was the first time that they discovered cold-welding, that usually is seen as something that we definitely don't want. Now, I don't go too much on the technical details, but this is the framework on which we are operating. Now, ASTROBEAT developed a very compact test rig with 4 testing chambers where we are testing different types of samples to measure in space the forces required to have a successful cold-welding adhesion. I'm saying this is a very compact experiment because thanks to SpaceX, prices went considerably down in comparison with 10 years ago, but it's still very, very expensive to send something to space and still extremely complicated. So here at MCAST, in collaboration with Southeast Technological University in Ireland, with a team led by Dr. Mark Wiley, which is a lecturer there, plus we have also a collaboration with New York University Abu Dhabi, we developed this experiment that was launched with a Falcon 9 rocket by SpaceX last 5th November. The Dragon capsule docked on the International Space Station, and these are the photos of ASTROBEAT in space. Now, these are very fresh news. Last Friday night, here in Malta, because we have a bunch of hours of difference with Houston, the scientific part was carried out successfully from the mechanical point of view. In terms of how these simulated damages to the hulls of spacecraft, how effectively the cold welding happened, we will see this when the payload will come back to Earth. From Florida will go back to Houston, from Houston will go back to Malta, from Malta we will send it to Ireland, where there will be the metallurgical analysis, and after ASTROBEAT will be back to Malta once again. But there is more to this. So, I mentioned I'm an aerospace engineer and a pianist. In the previous months, the collaboration with New York University Abu Dhabi. So New York University is the biggest private university in the world and is one of the main branches in Abu Dhabi. They are huge universities with incredible facilities, and they got interested in the potential for future developments for ASTROBEAT. Together with that, we have also the side of art humanities. So we developed a collaboration for the artistic part, and in particular, I was able to secure a collaboration with Grammy-nominated cellist Tina Guo and world-renowned producer Steve Mazzaro, that are also very well known and famous for their collaboration with Hans Zimmer. So from a point of view of public outreach, this is huge for us, above all for MCAST. And today there will be the first streaming event from space to Earth of the composition I developed together with Tina Guo and Steve Mazzaro. And on Wednesday there will be another streaming event with also music of the students of NYU Abu Dhabi. So, and these events will be streamed live on YouTube, and after, of course, will be available. Now, these are the two projects on which now Spartacus is building up. So we are investigating more the possibilities of cold welding adhesion, collaborating both with Southeast Technological University in Ireland and NYU Abu Dhabi. Now, two words about Southeast Technological University. First of all, the team and the research led by Dr. Mark Wiley is amazing, and we have a lot to learn. They are quite similar as a concept to MCAST at SET University. They have very good facilities, and the two institutions can learn a lot from each other. So we are better on some aspects, also in relation with opportunities for students. We are better in others. So it's a very interesting exchange. So we are building up also in terms of possible sensors for checking the damages in orbit. And in parallel, Also, we initiated a contact with Professor Panchenaumov, that has the biggest and most important team in all the Middle East area at the New York University Abu Dhabi. He's the director of the Center for Smart Engineering Materials, and they do very high-level research. And my interest as a researcher is above all in their capability of studying self-healing material. So, with a huge possible application for space and damages coming from space debris. Them, on the other hand, are interested in collaborating with a person that has a practical experience in bringing experiment to space. So also here there are huge possibilities for the near future, middle and long term. So, with this beautiful image of ASTROBEAT floating in microgravity on board of the International Space Station, I end here my presentation, and if there are questions, I'm happy to reply. Thank you.